In this video, we're going to talk about spread. So when you're looking at a quantitative variable, spread is simply asking how far apart are the values of the variable. If all the values are pretty close together, that means you have lower spread. And if the values are further apart, you have higher spread. So if I just look at a simple example here, I put these 5 numbers up, 3, 3, 4, 4, 5. Those are all pretty close together, but it's kind of relative. Just compare it with these, 1, 6, 7, 8, and 13. These are further apart from each other than these are, so this would have higher spread than this one. Now, measuring spread is a little difficult. There are 3 major measures. The simplest is range. Range is the distance from the minimum to the maximum value. You calculate it just as equals max minus min. The interquartile range is similar. Interquartile is between the quartiles. That's the distance from Q1 to Q3 then, and it's a similar calculation, just Q3 minus Q1. The weirdest one is called Standard Deviation, which is kind of a weird name to begin with. You can think about that as the average distance from the mean. That's calculated with equals stdev dot s, and then select the values. If you're in Excel, if you're in Google Sheets, it's something similar. If you want to calculate this by hand, it's a little more complicated. Maybe I'll put together a video on doing that, but you'll never have to in this class. It just takes too long. So let's look at an example using our temperature data. So here I took some Portland weather data, and I just added some filters to my month and years, and then I just did some copy paste to make this February 2013 versus February 2018. So let's go ahead and calculate all 3 measures of those spread just to see how far apart the values are. In this video, I'm focusing on Tmax. So we're sort of just asking how far apart are these values, and specifically we're just sort of comparing that to these values to see which year had more spread out values. And just looking at the 5-number summary that I put together over here, it looks like 2018 had the more spread out values because the min is 34, the max is 60, compared with 45 and 61. So these are similar up here, but this one is much lower, so we just expect that 2018 will have more spread. So the first thing we can do is range, then IQR, and then standard deviation you could just call STDEV. And so to calculate that, just do max minus min, 16, which makes sense. The distance from 45 to 61 is 16 degrees. Similar here, the way I set this up, I can copy and paste that over, 26 degrees. So it looks like these values are more spread out than these values, by which I mean Tmax for February 2018 is more spread out than Tmax for 2013. IQR will give us a similar result. We just do Q3 minus Q1. We get 5 for 2013, 9 for 2018. Interpreting this is a little complicated because what does 5 mean? Well, these are all in degrees, so it's 5 degrees, but can we really write a sentence or something about what that means in terms of the weather? Well, not really, but you can kind of think like, okay, you know, there was about 5 degrees difference between most days in February 2013. February 2018, there was maybe 9 degrees difference between most of the days. Standard deviation, do STDEV. .s stands for sample data. That's what I'll be using this entire course. There's also one .p, but we never have data on a full population. We'll talk about samples and populations a little bit more in another video though. So to do that, stdev.s, open paren, just select the Tmax values, close paren, enter. You get 3.78, and we can't copy paste that because if we do, it's going to reference the wrong column. But if I want to, I can, let's just type it in again. It's good practice. stdev.s, select Tmax here. Done. So we get 6.89 degrees. So either way we look at it, these are 3 measures of spread. Range is kind of the worst one because it just does max minus min. And if you had a really extreme big value or really extreme big value, that would be taken into account. IQR doesn't really care what your extreme values are. It's just looking at the 25th and 75th percentiles. Standard deviation does take them all into account. So if, for instance, this was much higher than 61, the range would change a lot, the standard deviation would change a lot, but the IQR wouldn't change at all. And interpreting these again is just you kind of think about how spread out are they. Most days we're about 5 degrees apart from each other is sort of a usual amount. Here we're saying there was about a 3.78 degree difference average from the mean. You could maybe make a sentence about that or something, but it's really important you know how to calculate them for right now.